Okay, let's move on to solve the challenge problem of the chapter 14 with the solid geometry. Okay, so the first problem is the base of the EFGH, and the right prism is a parallelogram of the FG is 6 and the EFG is 60 degrees. Okay, so first is we need to solve the EFGH, right? So we have this one is the EFGH with the EFG. Okay, EFG is 60 degrees. Then we have the EF is 8 and FG is 6. Now we have 8 and 60, right? So we have this one is 4 and this one is 4 root 3. Now we can solve the area. So the area of the EFGH is equal to the 6 times 4 root 3 is 24 root 3. Okay, now the B is what is the surface area of the EFGH, right? IJKL. Okay, so the surface area you can see. Okay, so it's 2 times of the EFGH. That's here, top and bottom, right? And the surface area here is 9, so that's why it's the perimeter times 9. Okay, so the surface area is equal to 2 SEFGH times 2. Then we plus the perimeter of the EFGH is 2 times the 8 plus 2 times 6 and times 9. Okay, so the answer is the 48 root 3 plus the 252. Okay, the C. So we want to do the volume, right? So the volume is very easy. It's the EFGH times the height. Okay, so this is the 24 root 3 times 9. Okay, so it's 216 square root of 3. Okay, so 2, the altitude from the vertex X or vertex V of the tetrahedron VWXY meets the surface WXY at the circumcenter of the WXY. So we have a base of the triangle is WXY, and we have a vertices of the V of the tetrahedron, and we know the V is the length of height, is the center, is the circumcenter of the WXY. That means we have the radius of the R, and R, right? This is the height. So now if you can see this, now you know the WV equal to the XV equal to the YV is also equal to the R square plus H square. Okay. So 33. Okay, so each side of the cube is shown has the length of the 10. Okay, then what is the volume of the solid whose edges are formed by connecting all the midpoint of the edges? So we have the 4 and the 4 and the 4. We have 12 edges, so we have 12 midpoint. And when we connect them, okay, so here you need to be very patient to take a look what is the constructed solid shape looks like. Okay, so let's connecting some lines to help you to see it. Okay, so now you can see we have some rectangle, right? So now you can see we have one solid shape like this times 1, right? And we also have 4 of this. So we can solve both of them. Okay, then we can solve the total volume. Okay, so the first, in order to solve this one, we need to solve the surface area, right? We know here is 10, and we're cutting like this. Is 5 root 2. Okay, so the area is what? The surface area is V equals the 5 root 2 of the square, right? This is the square. Okay, then we times the 10. $500. Let's solve the second part, okay, of this one. So we know this side, right, is equal to 5 root 2. So the area of this is equal to the 5 root 2 times 10. Okay, so the volume is 1/3 of the area times the height, right? So the height is equal to this, is 5 root 2, 5 over root 2. Okay, so that's why the area of this will be the 1/3 of the 250. That's one part, right? So we have the three part. So that's with called V1. This is V2. So V is equal to V1 plus 4V2. So and finally you can see it's the 2500. Number 3. A soccer ball is constructed using the 32 regular polygons with the equal size of the length. Then the 12 of the polygons are pentagon and the rest of them are hexagon. So we have the divided into the different polygons, right? We have the pentagon and the hexagon. Okay, then we have the numbers. So we know we have the 12 of them are pentagon, so the 20 of them are the hexagon. And the seam is shown whenever two edges are meet, right? So how many seams is how many edges, right? So let's counting the edges separately first, okay? So we have the 12 times the 5 is 60 edges. We have 20 times 6 is 120 edges, right? So think about it. So for any edges, okay, any edges is connected by two polygons, right? So each edge here is counting twice. So the total edge will be 120 plus the 60. Then we need to divide by 2 is equal to 90 edges. 35, okay? So here, okay, so we have the 10 equilateral triangles, and we have 5 squares are folded into a 15 square face of the polyhedrons. Okay, so how many edges and how many vertices? Okay, let's counting the number of edges. It's the same thing as what we do before. Okay, so it's 5 times 4 from the square. Okay, and 10 times 3 is from the triangle, and divided by 2, each counting twice. So we have 25 edges. Okay, then how many faces is we have the 5 plus the 10 is equal to 15, right? Here you know there is a Euler formula. Okay, to remember that, you can give yourself a very simple example. For example, use the cube. Okay, so for a cube, we have the edges is equal to the 3 times 4 is 12, and for the face we have 6, and for the vertices we have 8. So you can see 8 plus 6 minus 12 is over to 2. Okay, so the Euler formula tells us if there is a polyhedron, the vertices plus the face minus the edge must be 2 in the 3D shape. Okay, so now let's apply this one. So V plus the 15 minus the 25 is equal to 2. So V equals 12. Okay, Now next, so we have the octahedron is formed by connecting the centers of the face of the cube. So for a cube, okay, there are 6 faces, and so we have each face of the center. So we have the 6 centers. Let's see, this is 1, 2, 3, 4. 1, 2, 3, 4. Okay, so M, N, P, Q. Then here is the R. So you can see this is the half of the polyhedron, right? Okay, so in order to solve the volume, we need the base, right, and the height. So height here is really simple. Let's assume the ratio. Let's assume this is the 1, right? So the half of the height is 1/2, and let's see the surface of this is 1, 1, 1, 1, 1, and since we connected the center of the face, right? So this is the area. So that's why we have the 1/2 is 1/√2. So the area here is S of this area is the 1/√2 times 1/2 is half. Okay, now we can try to solve the volume, right? So the volume is 1/3, right, of the area is 1/2, right, times the height is 1/2, because this is only half of the octahedron. Then we have to times 2. So the area, the volume of the octahedron is 1/6, right? Now the volume of the cube is equal to 1 times 1 times 1 is 1. So now we can calculate the ratio is the cube over the octahedron is equal to 6. Okay. So next, a insect lives in the surface of on the surface of the regular tetrahedron. So we have a regular tetrahedron. Okay. The edge is 1, and it wishes to travel on the surface from the midpoint of the one edge, A, B, C, D, to the midpoint of the opposite edge. Okay, so we have 2 midpoint from the but for the opposite edge, I mean, because we cannot travel through the spacing, right? We have to travel through the surface. Okay, so what is the shortest path? So in this case, we always do is to unfold the surface, okay, and then find the distance, the straight lines between the 2 points. So this is ABC, okay, ABD, I'm sorry, this is the ABD, and now let's splitting this to, so we're splitting the C1 and the C2. So you can see, because each one is equilateral, right? 60, 60. So this is this. And we also have the C2. This is 60, 60, 60. Okay, so the end point after folding, right, it will be somewhere here. And the end point is somewhere here, right? So we know this is the 1/2 and this is the 1/2 by the symmetry. This is 1/2, right? You know this is the parallelogram here. So that's why the MN is equal to the AD is equal to the 1. This is the shortest path if you travel along the surface. And this is the point of the surface, means we travel through this point is, okay, this is the half, it's the midpoint. This is the shortest path, P. Okay. Next, so we have the ST, we have the STUV WXY is a right regular prism, and with the XY of 12, and this one is 3. Okay, rectangle, it's a rectangle, it's 90 degrees, and the Tx is equals to 4. Then find the WU. Okay, so find WU is really simple, so we can connect it this line, right? So we have a two Pythagorean, right? So for first A, you need to see the triangle WXY is a right angle, is a right triangle. So the WY is equal to 3 square plus the 12 square, right? Is equal to the 3, then it's the 17. Okay. Then the second one, you need to see the right triangle WYU, right? Is a right triangle. Then you can see the WU is equal to the 9 times 17, then plus the 4 square is 16, right? Is equal to the right. Okay, so now let's solve the B. So find the distance from the Z to WU. Find the distance from Z to the WU. Okay, so if we want to find the distance from the Z to the WU, now we need to see the okay, so we need to find the Z to the WU. Okay, so now let's see. So we can try to prove the WU is perpendicular to a face, right? Okay, now let's do this. Okay, so let me draw this one. Let me draw a big picture. Okay, so this one, okay, P. Okay, so now we can see, okay, so the Z PQ, okay, so we can see the ZQ, right, is parallel to the ZQ is perpendicular to this edge and also perpendicular to this, so ZQ is perpendicular to this face. So that's why the WU is perpendicular to ZQ, right? And also WU, we can do WU is perpendicular to PQ, right? So WU will be perpendicular to face of the PQZ triangle, okay? So that's why we have the WU will also perpendicular to the PZ, right? So now we can do it, okay? So and also because the ZQ also perpendicular to face WU, what's that, WUY, okay? So now the ZQ is also perpendicular to the PQ. Okay, so we can try to use the Pythagorean theorem if we solve the ZQ and the PQ, right? Okay, now let's solve the ZQ first. Okay, so what is the 312? Okay, so 312 it's 3 and 12. Okay, so the ZQ will equal to ZQ times the WY is also equal to 3 times 12. Okay, so that we can solve the WY. Right? So ZQ is equal to, what is the WY is 3 root 17. Okay, 3 root 17, so it's 12 over root 17. Okay, so we solved the ZQ, right? Now we want to solve the PQ. Okay, to solve the PQ, okay, we need to have the we need to know the similar triangle, right? We need to know the WQ. Okay, let's solve the WQ first. So we know the ZQ W, right? So here is the 12. The ZQ is 12 over 17, right? So now we can calculating the WQ, right? So it's 12 times the 4 over the 17, root 17, right? So now we solve the WQ, right? So the WQ, PQ over WQ, okay, is equal to the UY over WU. Okay, so now we can solve the PQ is equal to the WQ, that's 12 times 4 over root 17, then times the UY. UY is 4 over 13. Okay, so once we have the PQ and the ZQ, okay, now we can solve the PZ. That's the Z to the line of this, right? This one is equal to the ZQ square plus the PQ square is equal to the 144 over 17 plus the 17, okay, is 144 times the 256 over 169 is equal to 144 over 17, right? The 256, 169, the what is that? 256 plus 169 is 5 is 2 4 is equal to Okay, it's 25, right? So this equal to the okay. So now we solve we find the distance from Z to the line, right? Okay. The next one is the find the volume of the TWXY. Okay. Okay, TWXY. Find the volume of the TWXY. T is here. WXY is here. Okay, so this one is simple. 3 and 12 and 4. Okay, TWXY. So we have the TWXY is like this. Okay, so 3, 12, and 4. This is the height. So volume is 1/3 of the half of the 3 times 12 then times 4 is equal to, it's the 36 divided by 6 is 36 divided by 6 is 6 times 4 is 24. Okay, then what's next is find the volume of the pyramid of the VSU YW. Okay, now let's see the pyramid of the VSU YW. Okay, so the VSUY, right? We need to try to solve the VSUY first. So let's solve the D here. Is SVSUY is equal to the 3 times root 17 times the height is 4 is 12 root 17, right? Okay, the V to the from the V to the height, right, is this. Okay, so we already solved the distance. It's simple to solve this is the 3 and the 12, right? So 3 times 12 is equal to the 3 root 17 times h. Now we can solve the h is 12 over root 17. Okay. Now we can solve the volume, right? Is equal to 1/3 of the 12 root 17 times the 12 over root 17 is equal to the 4 is 48. Okay, the final one is the find the volume of the VXZU. Okay, find the volume of the V, then XZU, XZ with a Z, XZU, VXZU. Okay, let's see. Let me draw it here. Let's redraw it, okay? Otherwise, it's hard. Okay, STUV, then WXYZ. Okay, so z zxu zxu zxu. Okay, so we have the v, x, z, and u. Okay, so you can see it's like this. Okay, so we can see this is the vertices as a Vx, right? We have the base is U, V, Z, right? So the base will be is 3, and this is the 12. So the base is the it will be 1/3, right? The base is half of the 3 times 4, right? And the height from the x to the base is like is the xy, right? Is so this is the 12. So the answer is 24. Okay, so that's the first section of this problem. That's another video.